Welcome to UGC EPG Pathshala. We shall discuss today Climatology Module 14, that is on monsoon definition, theories and controlling factors. Introduction. The term monsoon is derived from Arabic word mawsim, meaning season. Arabians were known to general pattern of winds in different seasons. As such, Arabians used to sail their ships for the movement of goods and people. It is believed that seamen used to describe alternating winds in Arabian Sea, where they appear to blow from northeast for 6 months and from southwest for another 6 months. Seasonal alternating of wind direction and speed was used by early seamen to trade from India to Arab and African countries during winter and return trade from African and Arab countries to India during summer. In addition to this, economy and society in tropical world depends directly on the success of monsoon. The failure of monsoon upsets the socio-economic balance in the region. Behavior of monsoon is erratic because of heavy rains in some parts of the region. The areas are flooded, while in other parts there are severe drought conditions. Since monsoon plays a central role in socio-economic life of the region, it is embedded in socio-cultural milieu of the people in monsoon lands. Objectives of the study. After studying this module, you will be able to define monsoon. Discuss major characteristics of monsoon, differentiate between summer and winter conditions of temperature, air pressure and wind direction, examine factors favoring occurrence of monsoon, explain different theories related to origin of monsoon, analyze role of upper and surface air circulation, mechanism of monsoon and explain the significance of monsoon on socio-economic part of the life. Historical context of monsoon. The term monsoon appears in early writings of Greek, Indian, Buddhist and Arab scholars. However, credit for the first scientific studies of monsoon winds goes to the Arabs. Al-Masudi, Baghdad based an Arab scholar, gave an account of reversal of ocean currents and monsoon winds over North Indian Ocean. Sidi Ali, another Arab scholar, could calculate the precise dates of commencement of monsoon at several places. Sir Edmund Halley, an English scholar, opined in 1686 that monsoons are the result of thermal contrast between continents and oceans, oceanic areas having due differential heating. According to Halley, conceived the idea of summer and winter monsoon depending upon the season. The idea of Halley prevailed for about 3 centuries. Although Halley's idea is not outrightly rejected, recent studies after 1950 have thrown significant light on the genesis of monsoon. During these years, contribution of Flown, Thomson, Stephenson, Frost, In, Huang, Takakasi, Parmain, Newton and Indian meteorologists including Koteshwaram, Krishnan, Raman, Ramanathan, Krishnamurthy, Ramarattan, Ramaswamy, Anantakrishnan etc. have contributed significantly to the study of monsoon winds definition now. Scholars engaged in studies of climatology and meteorology have defined monsoon from different angles. Some of the commonly used definitions have been given below to explain the wider context of monsoon. Monsoons are the large scale seasonal wind systems blowing over vast areas of globe persistently in the same direction, only to be reversed with change of season. Ramashastri. That the monsoon represents simply a land and sea breeze on a large scale, and that the annual period of monsoon corresponds to diurnal period of breezes Angat, Han and Köppen. Whereas monsoon climate appear to be very complex in detail, their fundamental principle, that of land and sea breezes on large scale, remains simple and straightforward. Miller. Then according to New World, the word monsoon is used only for wind systems where the seasonal reversal is pronounced and exceeds a minimum number of degrees. The term has been applied to wind system which shows at least 120 degrees of change of wind direction with change of season. These winds are characterized by consistently higher than 40% and a mean resultant speed of more than 3 meters per second. According to Cheng Chia Cheng, monsoon is a flow pattern of the seasonal atmospheric circulation over a wide geographical area, which there is clearly dominant wind in one direction every part of the region concerned, but in which this prevailing direction of wind is reversed or almost reversed from winter to summer and from summer to winter. The term monsoon is broadly used to denote the cyclic reversal of pressure and wind systems in a year. Such a seasonal reversal of pressure and wind system is associated with sequential changes in the cloud and weather patterns, mainly in tropics. Monsoon as a system of wind has the following features: a system of winds with marked seasonal shifts caused by differential heating of land and sea in response to incoming solar radiation on the earth's surface; a system of wind that is largely confined to tropics, a region between 20° north to 20° south on both sides of equator. Monsoon over northern hemisphere are trade winds of southern hemisphere. On crossing the equator, the winds are deflected to the right due to earth's rotation. Consequently, winds blow in southwesterly direction. In the same way, on southern hemisphere, monsoon are the trade winds of northern hemisphere, which on crossing equator are deflected to the left due to earth's rotation. Consequently, winds blow in northwesterly direction. Monsoon winds are more pronounced in months of July and August in tropics of northern hemisphere and in January and February in tropics of southern hemisphere. Thus, summer season in tropics of both the hemisphere coincide with the monsoonal wind and rains. Monsoon winds with other continental masses of the earth are not so well marked as Indian monsoon. Seasonal wind changes have been known to occur in northeast Australia, Africa, South America, Brazil, southern USA and in Latin America. Figure 1 presents the classic monsoon region. It is obvious from the map that monsoon region develops in tropical belt. They are, however, well developed in and around Indian Ocean. Theories of origin of monsoon. Origin of monsoon is a complex and meteorological and climatological phenomena. Scientists have developed theories to solve the mystery of the origin of monsoon. There are broadly three groups and following categories: classical theory, dynamic theory and modern theory. A brief discussion of each theory is given below. Classical theory. The theory was propounded by Sir Edmund Halley in 1686. It was further expanded and supported by Hahn, Köppen, Miller. As per theory, monsoons are the extended land breezes and sea breezes on large scale produced by differential heating of continents and oceans. The response of continents and oceans to solar heating energy creates a striking difference in surface pressure condition and movement of local winds. Most of the solar energy received at the ground by the continents is used up heating the air. Only a shallow few meters of is energy received for the ground for continents. Contrary to the solar energy, much greater depth to the oceans because of water being good conductor of heat. Consequently, smaller part of this available for heating the air oceanic areas. Is that rise of temperature summer is much less during ocean, whereas it has that the mean summer temperature over the continents often exceeds those of oceanic areas by 5 to 10 degrees Celsius. The situation is the reverse, and storage of ocean temperature leads to change during summer season. In northern hemisphere, a thermally induced low pressure centers develop in Thar, Arabia and Sahara, and elongated a long pressure belt from Sahara to India marks thermal contrast between continents and oceanic areas, cause a sea to land air pressure gradient. Summer season, and as a consequence of normal wind system from northeast is reversed to southwest. The air moving from oceans towards the continent is warm and moist. Land barriers as mountain plateaus, they obstruct the motion, and air ascends along the land barriers and causes precipitation. Land barriers such as Western Ghats, southwest warm and moist air cause rainfall along west coast of India. Contrary to the Aravallis hills having north-south extension similar to that of Western Ghats failed to create much of rain. Absence of oceanic proximity, as such moisture laden winds from Arabian Sea weaken by the time they approach Aravalli areas. Hence, cause of scanty situation in south west monsoon, it is depicted in figure 2. Pressure were developed one central India and another highland of Central Asia. Because of relatively low temperatures, southern winter A high pressure belt develops in central Australia and southern part of Indian Ocean. Similarly, conditions of thermal contrast during winter season cause a land to sea air pressure gradient. The change in pressure pattern begins by September in northern hemisphere with the apparent movement towards Tropic of Capricorn. Temperature begins to decrease while air pressure starts increasing in northern hemisphere by December. January, a high pressure gets fully established in northern hemisphere with its center near Lake Baikal, that is 1035 MB, and in northern Indian plains. Compared to these continental areas which are cold and zones of high air pressure, heat storage of ocean leads to record a higher temperature and low air pressure during winter season. As a consequence, winds flow from continents to oceanic areas in northern tropics. Since air moving from land is cold and dry, it is incapable of giving any precipitation unless it comes in contact with large water bodies like sea and ocean. But in case of Tamil Nadu region of India and in Sri Lanka, northeast trade winds cause sufficient rainfall because they pick up moisture from Bay of Bengal on the way from northeast to southwest. The position of sun is overhead close to Tropic of Capricorn in December and January. Low pressure develops to the south of equator along Tropic of Capricorn and in central Australia. As a consequence, there is an outflow of air from oceans towards continental areas. Northwest monsoon is active in southern hemisphere and causing heavy rains in Australia and areas close to Tropic of Capricorn. Criticism and limitation of this theory is that origin of monsoon suffers from certain limitations which are discussed. Basic premise that high thermal condition over land cause low atmospheric condition resulting in air movement from oceanic which are related to low thermal conditions during summer season. It does not seem to explain the origin of monsoon fully, as highest temperature in land areas are usually associated with the months of April and May, when there is complete absence of rainfall. Monsoonal rainfall are not solely orographic, rather they are a jointly produced phenomenon with convection and cyclonic situation. Surface and upper air circulations are usually opposite in their orientation. Had the origin of monsoon been thermally induced, there need not be any anti-monsoon air circulation in upper air, which is not so in some of the cases. Now, the theory does not take into account circulation of oceanic water, which is a major cause of thermal contrast among the oceans. The theory also ignores upper air circulation, which serves as the base for the intensity and extension of summer rainfall in tropics. Now, the second theory, that is dynamic theory. It was propounded by Flohn, a German meteorologist, in 1951. The theory was further enriched by the researches of Krishna Rao, 1952. It is also known as theory of shifting pressure and wind belts. According to Flohn, monsoon is the result of seasonal migration of planetary winds and pressure belts. The trade winds from both the hemispheres converge near equator and form intertropical convergence zone. The northern and southern limits of ITC are NITC and SITC respectively. A narrow belt of doldrums lies between NITC and SITC and is characterized by equatorial westerlies. During summer solstice, trade winds of southern hemisphere, that is southeast trade winds, extend and shift northward, while during winter solstice trade winds of northern hemisphere, that is northeast trade winds, extend and shift southward from their normal position. The southeast trade is associated with equatorial westerlies, produce southwest or summer monsoon around summer solstice when sun is overhead at Tropic of Cancer. Similarly, around winter solstice when sun is overhead at Tropic of Capricorn, northeast trades in association with the equatorial westerlies produce northwest or winter monsoon. Thus, shifting position of pressure and wind belts due to dynamic motion of the earth is responsible for the origin of monsoon and reversal of wind patterns in the tropics. Obviously, the shifting of ITCZ is responsible for the reorientation of the pressure and wind conditions in tropics. The figure 4 represents the location extent of ICTZ in January and July, which helps us to understand. Now, the criticism of dynamic theory. The apparent change in the position of sun caused north and southward shift of ITCZ. There is an associated change in the pressure condition over land and sea in tropics belt. The directional change of wind is more pronounced around Indian Ocean, which has alternating distribution of land and sea. The theory has a scientific significance in explaining the origin of southwest and northwest monsoon in association with the movement of planetary trade winds. However, theory carries some limitations. They are discussed as such. Theory does not take into account the role of upper air circulation, which remains significant in maintaining the rhythm of monsoon for a fairly long period of time and over extensive areas in tropics. Theory seems to have ignored the oceanic circulation and temperature gradient in oceanic waters. Position of air masses warm and cool and their gradual shift from tropics is one of the potent factors that affect the origin of monsoon. Theory does not seem to include those vital elements. Now, the third theory, that is recent theory. With the advancement of satellite technology, precise weather prediction instruments and global network of meteorological observations, a large and varied data is now available to process through computers, develop models and arrive at very precise results about weather and climate. The recent theory related to origin of monsoon is based on observations concerning upper air circulation, temperature conditions over Tibetan Plateau, jet streams, oceanic water circulation, the occurrence of El Nino and La Nina and southern oscillation. A brief discussion on some of these elements is explained. Monsoon conditions expedition. To understand the causes and mechanism of monsoon, an Indo-Soviet joint expedition carried out in 1973. The monsoon expedition is popularly known as MONEX. It was jointly organized May-June 1973. 4 Soviet and 2 Indian ships equipped with scientific tools of meteorological observations were used to take precise observation in Indian Ocean, Bay of Bengal and Arabian Sea. Dr. P. Koteshwaram and Professor F. Flown suggest that Tibetan Plateau is a source of heat for the upper atmosphere. The rising temperature in higher altitude generates an area of rising air motion. During summer, Tibetan Plateau remains warmer by 2 to 3 degrees Celsius than the adjoining areas. The low pressure created in Tibetan Plateau pushes westerly jet further northward. It coincides with the arrival of Indian summer monsoon. The southward blow of air from Tibet helps to strengthen the prevailing easterly winds over south. It explains the easterly jet at the time it approaches the monsoon. The context shown by the diagram, according to Muang to In, there is a correspondence between shifting of jet and slowing down of westerly jet over whole of Eurasia. As against this, plateau of Tibet becomes very cold during winter and serves as the most important factor in advancing the westerly jet to the south by mid of October. It helps in establishing cold wave and western disturbances over North Indian plains, resulting in high progressive pressure over land surface and low pressure over Indian Ocean. These meteorological conditions help in causing favorable monsoon. Jet stream and monsoon. Now, the second aspect of this, jet streams are prominent movement in upper level wind flows. These streams are concentrated meandering bands of geostrophic winds traveling at a speed of 30 to 40 km per hour. Jet streams are general circulation of upper atmospheric similar to planetary wind system, support of the earth between equator and about 30 degree north, in which there are easterly trade winds. At lower levels there are westerly aloft. In middle zone between 30 to 60 degree north, in which there are westerly winds at the earth surface and easterly winds aloft. Finally, between 60 degree north and north pole, where surface winds are easterly and upper winds are from westerly direction, that is given in the figure 7. Easterly jet streams was first inferred by Koteshwaram and Krishna in 52. The core of the easterly jet is at 13 km 150 MB, while that of westerly jet is as 9 km from the surface. The axis of strongest winds in the easterly jet may extend from southern tip of the Indian peninsula up to the Tropic of Cancer. Jet stream, particularly westerly jet, plays a decisive role in origin of Indian summer monsoon. Observations reveal that northward push of westerly jet due to heating of Tibetan Plateau marks the onset of Indian summer monsoon. As against this, westerly jet stream is located to the south of Himalayas during winter season. The winds tend to descend along northwestern part of India, which coincide with the occurrence of western disturbances in the region common during winter season October to March. These disturbances result in occasional rain, which is highly beneficial to the standing winter crops. The tropical easterly jet descends in permanent high pressure area formed over South Indian Ocean with further intensification of high pressure gradient over Indian Ocean. The vigor of summer monsoon increases sharply. The facts related to air pressure, wind pattern, upper air cell, jet stream and Indian Ocean dipole and summer monsoon have been displayed through figure 6. Next, teleconnections and southern oscillation. The El Nino meteorological observations reveal that there are teleconnections between occurrence of weather phenomena at one place and its effects over time at another place. Based on the premise of teleconnections, origin of monsoon has been explained with the reference to El Nino, La Nina and Indian Ocean dipole. El Nino and the monsoon. The effect of El Nino on summer monsoon is significant. El Nino is a warm ocean current appearing along the coast of Peru. The literal meaning of El Nino is a child, Christ and or a little boy, and it develops generally in December. Peru or Humboldt is a cold current flowing along the coast of Peru. The appearance of El Nino reverts the condition of Peru current by developing a warm water and moist air conditions over eastern Pacific, that is Peru coast. The cold conditions in western Pacific coast along eastern Australia, Indonesia as a result of eastern Pacific along Peruvian coast in South America records high rainfall, while western Pacific along Australia and Indonesia coast record drought condition. El Nino results in weakening of the monsoon, causing drought condition and crop failure in monsoon regions of South and Southeast Asia, figure 7. The warming of Indian Ocean under the influence of El Nino weakens the intensity of monsoon. La Nina and monsoon. La Nina, the word originates from Spanish meaning little girl, is characterized by unusually cold season, cold ocean temperature in equatorial Pacific. During period of La Nina, sea surface temperature across equatorial eastern central Pacific ocean will be lower than the normal by 3 to 5 degrees Celsius. It has extensive effect on the weather in North America, even affecting Atlantic hurricane season. La Nina caused heavy rains over Malaysia and Philippines and Indonesia. Western side of the equatorial Pacific is characterized by warm, wet and low pressure weather as collected moisture is dumped in the form of typhoons and thunderstorms, that is figure 8. The ocean is some 60 centimeters higher in western Pacific compared to eastern Pacific. As a result of this motion, the water and air is returned to the east. Both of them are now much cooler and air in surface much drier. Southern oscillation and monsoon. The system of southern oscillation was worked out by Sir Gilbert Walker, the first Director General of IMD in 1924. It is a seesaw pattern of meteorological changes that are often observed between Pacific and Indian Ocean. It has been established that when surface air pressure is high over Pacific, air pressure over Indian Ocean tends to be low. Since surface air pressure over ocean during dry winter season is inversely related to summer rainfall, prevalence of low air pressure over Indian Ocean during winter season is a sign of positive southern oscillation. The chance of favorable monsoon are generally linked with the positive southern oscillation. On the contrary, if air pressure is high over Indian Ocean during winter season, it denotes negative southern oscillation, which means that coming monsoon will be weak. Southern oscillation has a period of ranging between 2 to 7 years. The intensity of southern oscillation is worked out by a difference in sea level air pressure at Tahiti, that is 180 degrees south and 149 degree west, a station in mid Pacific, and Port Darwin, that is in Australia, representative station of Indian Ocean. A negative value of Southern Oscillation Index SOI implies low pressure over Peru coast and high pressure over North Indian Ocean during winter season, explaining a poor monsoon phase. There seems to be a close correlation between appearance of El Nino and negative SOI. The two adverse parameters, negative SOI and El Nino, and the cause of a weak monsoon phase. Together, these parameters are known as INSO event. Indian Ocean Dipole IOD. It was in 1999 the phenomena of IOD was identified and was linked to the origin of monsoon. Scientists have concluded based on their long term observation that there are marked variation in thermal as well as atmospheric condition of eastern and western part of Indian Ocean during winter month December to January. These conditions are decisive for significance of summer monsoon in Indian Ocean region. Apparent changes in thermal and atmospheric conditions of tropical Pacific Ocean are known as El Nino, while development of similar conditions in tropical Indian Ocean is known as Indian Nino. Indian Ocean Dipole has three situations. Positive IOD occurs when summer Sumatra in Indonesia remains colder than normal and western coast of Indian Ocean along Africa remains warmer than the normal. Such a situation is favorable for good monsoon. In such a situation, air pressure in eastern Indian Ocean is greater as compared to the western Indian Ocean. Presence of Agulhas warm current in western part of Indian Ocean and western Australian cold current in eastern part of Indian Ocean are major factors controlling for the development of such a situation. Negative IOD develops when Sumatra in Indonesia remains warmer and Malagasy in East Africa remains colder than normal during winter season, that is December January. The negative IOD results in weakening of the summer monsoon. Normal IOD refers to the normal thermal conditions over western and eastern coast of Indian Ocean during winter season. Temperature and air pressure conditions do not vary significantly. Such a situation indicates about normal summer monsoon. Limitation and criticism of the last theory, that is recent theory. Theory offers adequate insight into the origin of monsoon. It has a wide acceptance. However, there are some limitations of the theory which are explained. Despite several merits to its credit, theory does not take into account spatial and temporal trends of weather and climate which are in the process of continuous change and are in cause of upsetting the normal conditions. As a consequence, there is an increase in the extreme weather conditions in the tropical world unless theory takes into account extreme situations into its ambit. Mechanism of origin of monsoon remains partly explained. Periodicity and effectiveness of the monsoon seems to be more affected by human interventions in nature and degradation of ecological conditions. As such, parameters related to human activities such as emission of carbon and other CFC gases into environment and upsetting of ecological balance deserve to be considered while explaining the origin of monsoon. Prevalence of temperate conditions, that is temperature, pressure, air masses during winter and its role in origin of summer monsoon, surface configurations such as land barriers and their orientation, extension of island groups in oceans, proportion of oceanic expansion also play a decisive role in advancement and intensification of monsoon. Controlling factors. There are factors that exercise sufficient control over origin and mechanism of monsoon. They are grouped into global, regional and locational factors that play a decisive role. Global factors. Among the global factors, temperature and air pressure conditions on the earth surface and upper air circulation in the higher altitude exercise effective control on monsoon. Recent researches have shown that global temperature rise has resulted in upsetting the trends of precipitation globally. Conditions of air pressure are partly controlled by temperature conditions and partly by the motions of oceanic waters. The mechanism of upper air circulation and the descent of rising air to the ground, meteorological conditions during winter, temperature and pressure gradient over oceans and continents, precipitation in temperate and tropical zones are some of the determinants of monsoon that operate globally and exercise their influence in the mechanism of monsoon. Now, regional factors. Monsoons are largely considered to be a regional phenomenon. Topographic controls such as Himalayan arc, Tibetan plateau, Shillong plateau, Western Ghats, Arakan-Yoma mountain chains, presence of hot deserts on the western margins of the tropical continents and location of island groups in proximity to equator exercise effective control on the origin of monsoon. It is very well known that large part of heavy rain that falls on the west coast of India is caused by topographical barrier of Western Ghats. Regional meteorological observations such as floods in Nile, intensity of higher rains in Abyssinian plateau and Zanzibar group of islands in tropical Africa during summer persistence of cold wave in northern plains of India, extension of Siberian air mass up to Indian subcontinent and low air pressure conditions over Indian Ocean during winter are some of the regional factors that exercise influence in the mechanism of summer monsoon. The locational and situational factors. Besides above, there are some locational and situational attributes that also exercise control over the effectiveness of the monsoon. Altitude, orientation and extent of vegetal cover in physical barrier augments the prospects of precipitation at a place. The west-east orientation of Himalayan arc serves as factor of control for monsoon winds during summer. While there is a heavy rain to the south of Himalayas, the areas north of Himalayan region remains dry and cold for most part of the year. Himalaya serve as a source of high altitude heat transfer towards north during summer and facilitator for the transfer of cold wave towards North Indian plains during winter. This characteristic plays a vital role in initiating the monsoon circulation over South and Southeast Asia. Tibetan Plateau lying between Himalayan mountain system in south and Altai mountain system in the north acts as a factor in the origin and effectiveness of monsoon. Tibetan Plateau remains warmer by 2 to 3 degrees Celsius than the adjoining areas during summer. The low pressure created in Tibetan Plateau pushes westerly jet further northward and strengthens the easterly jet, which coincides with the appearance of the arrival of Indian summer monsoon. Summary and conclusion. The term monsoon is broadly used to denote the cyclic reversal of pressure and wind system in a year. Such a seasonal reversal of pressure and wind system is associated with sequential changes in cloud and weather patterns, mainly in the tropics. The monsoon plays a pivotal role in socio-economic life of the region. It is embedded in socio-cultural and milieu of the people in the monsoon land. Thus, economy and society in general, the tropical world depends directly on the success of monsoon. Failure of monsoon upsets the socio-economic balance of the region. Behavior of monsoon is erratic due to heavy rains in some parts of the region and areas are flooded, while other parts there are severe drought conditions. The classical theory of origin of monsoon states that during summer solstice sun is overhead at Tropic of Cancer. It results in high thermal conditions over continents during summer, causing atmospheric pressure conditions. Consequently, air movement from oceans to continents takes place as oceans are related to relatively low thermal conditions during summer season. The winds blowing from the apparent changes in the position of sun causes north and southward shift of ITCZ during summer and winter solstice. There is an associated change in the pressure and conditions over land and sea in the tropical belt. Directional change in the wind is more pronounced around Indian Ocean, which has alternating distribution of land and sea. Consequently, winds from oceanic areas blow towards continents, which are the source of regions of high temperature and low air pressure during summer season. The theory has a scientific significance in explaining the origin of southwest and northwest monsoon in association with the movement of planetary trade winds. Recent theory related to origin of monsoon is based on observations concerning upper air circulation, temperature condition over Tibetan Plateau, jet stream, oceanic water circulation, occurrence of El Nino, La Nina and southern oscillation, Indian Ocean dipole. Tibetan Plateau is the source of heat for upper atmosphere. The rising temperature in higher altitude generates an area of rising air motion. Low pressure created in Tibetan Plateau pushes westerly jet further northward. It coincides with the arrival of Indian summer monsoon. The southward blow of air from Tibet helps to strengthen the prevailing easterly winds over South India. It explains the appearance of easterly jet at about the same time as the appearance of Indian monsoon. The effect of El Nino on summer monsoon is significant. Warming of Indian Ocean under the influence of El Nino weakens intensity of monsoon. El Nino results in causing drought conditions and crop failure in monsoon regions of South and Southeast Asia. System of southern oscillation is a seesaw pattern meteorological changes that are observed in Pacific and Indian Ocean. It has been established that when surface pressure is high over Pacific, air pressure over Indian Ocean tends to be low. Since surface air pressure over oceans during dry winter season is inversely related to summer rainfall, prevalence of low air pressure over Indian Ocean during winter season is a sign of positive southern oscillation. Chances of favorable monsoon are generally linked to this positive southern oscillation. On the contrary, if air pressure is high over Indian Ocean during winter season, It denotes the negative southern oscillation, which means coming monsoon will be weak. There are marked variations in thermal as well as atmospheric condition of eastern western part of Indian Ocean during summer months. These conditions are decisive for significance of summer monsoon in Indian Ocean region, when western Indian Ocean remains warmer than eastern Indian Ocean during winter. It is said to be positive IOD, which is indicative of favorable monsoon. Contrary to this, if situation is reversed, it is said to be a negative IOD, which is indicative of weak monsoon phase. It is thus obvious that mechanism of monsoon is complex phenomena, and scientists are still engaged in decoding the mysteries of monsoon. Recent theory presents scientific explanation and is widely accepted. In terms of controlling factors, there are global, regional and locational elements that exercise influence on the mechanism of monsoon. Surface air circulation over continents and oceans and upper air circulation has direct bearing on the intensity of monsoon. Rising temperature globally upsets the mechanism of monsoon and turns it erratic. Regional elements such as land barriers, distribution of ocean condition, orientation of the earth's surface influences the monsoon. Local elements such as forest cover, expanse of water bodies, windward orientation also influence the intensity of precipitation locally. Thank you very much.